Okay, hello everyone. Solutions here for the test. Sorry I can't be with you to go through the test today, but I'm going to go through the test here. I want you to watch this video. I want you to go through the test, listen to it as I'm going through it, see the different things. I've got my notes here with a few things on it as well. Lots to learn from it. Please, this test wasn't great, but lots to learn. Let's focus on the forward path, not the path behind. Notes over the whole thing I had here was rounding. Rounding was a really big issue. You round only the final answer. Everything on the way through, you keep all the numbers on the way through, round the final answer only. Usually 2 decimal places is a good spot to be, but read the question. Sometimes it says to the nearest whole number. Show logical working. So many of you jump steps and then you got lost, or I couldn't follow it. You've got to tell a story with your maths. Tell a story. Tell me what's happening. And the last one was units. If a question's got units, you've got to use it. If it's a measurement one and there is no units, then you've got to say units squared or units cubed. Make some note that you know that units was a key part of the question. Let's get cracking through this. Here we go. So, first question there. What we're really doing is using our triangles. You should know these. You remember Pythagoras works. 1 squared plus 1 squared is 2. Square root 2. This becomes 3 plus 1, 4. Square root 2. We know these work. So cos of 150 degrees. Remember, we've got to think, hang on, cos of 150 is all the way around here. Isn't that 180 minus 30? So therefore the equivalent angle is 30 degrees. But cos gets us there, gets us positive square root of 3 over 2. We're over here, negative square root of 3 over 2. I'm moving quickly, you can watch it again if you need to. Sine of 135, again, 135 over here, isn't that 180 minus 45? So therefore sine of 45, but sine we measure on the vertical axis. So sine of 45 and sine of 135 still gives me the same positive value. So there we go, 1 over square root of 2. Rationalise the denominator if you want to. Some of you did that, good job. Either was fine. Tan of 60. Now, tan of 120. Again, tan of 120. Over here somewhere, doesn't that mean that we drag it back down there? It's going to be negative, isn't it? Right? So, tan of 120, isn't that the same as the tan of 180 minus 60? So let's go for tan of 60. We get a positive value, make it negative. There we go. Square root of 3, negative square root of 3. And where did I get the numbers from? I used these triangles here, didn't I? Right? There we go. Question 1, done. Question 2. Oh, Miss Warmer's made a mistake here. She didn't tidy this up. Look, we were okay. 19 degrees. This was meant to be 19. Doesn't matter. Let's move on. Sine of 19 degrees. Well, these numbers right here, aren't they telling us what we need? Isn't that the x-coordinate and the y-coordinate? Now we remember that sine is measured here. So the y-coordinate of 0.3304 is what we want here, but it did say to 1 decimal place, 0.3. Cos of 161, like above, 161, 180 minus 19. So wouldn't that give me some value over here, which is really this 0.99944, but negative. Round it, negative 0.9. Tan 199. Well, that's this one here. Isn't that 180 plus 19? So it's going to be a positive value for my tan axis, right? But tan, I remember, is y over x. Tan, opposite over adjacent. Tan of an angle is the opposite over the adjacent. Here we go. Our rounded value, 0.3. Done. All right, moving on. Got to keep going. Here we go. Easy question. This was easy. We should have got this. Remember, radian measure says that this angle here is measured on the outside. How many radiuses fit into this? Well, 12 divided by 8. That's it. That's it. The radius, the radians, the radius, the outside bit, how many of these fit into there? Done. Same question. Easy marks. We should have got those ones. 27 divided by 6, 4.5. Done. Moving on. Here we go. Okay. So this one, good question here, Miss Warmer. It's very good. So we're given the outside angle, pi on 3. Okay. Throw it in here, it's 2 pi on 3. Got to add to 3 pi on 3, or pi. Pi is 180, 2 pi on 3. If you want to change to degrees, 60, 120, either's good, doesn't matter. Didn't have to work in degrees or radians. Here we are, cosine rule. Cosine rule. X squared equals this one squared plus this one squared minus 2 lots of this times the cos of this. There we go. 1 mark for writing that out. Number crunching, lots of errors in here. Minus, minus, right? That was an issue. And this one, recognising that it's going to be minus. Now, revise that question above. Question 1, that's where all this came from. Done, done, done. Answer. Now, Miss Warmer's didn't get, she wouldn't have got full marks here. We're in metres. No metres there. Put metres. Anyway, moving on. Here we go. Question number 5. In a right angled triangle. Some of you saw this little trick. Right angled triangle. We don't actually need to use that. Nah, don't need it. We've got 2 sides. We can work out the third just with Pythagoras. Easy. But you could have also used the cos A 3 over 4. Put it in here. You can see what Miss Warmer's has done here. And then work it out from that as well. This was easier. Now, 63. 9 times 7. Right? 9's a square number. I can tidy up. This would have been okay, we paid that, but try and see this as well, okay? Good. Now, next question, very good question, very good question. This was the key issue. This was the key issue. The sine of a particular angle was this. That's not the sine of 0.8. No. The sine of the angle was equal to 0.8. The angle would have been some, I don't know, 30 degrees, 50 degrees, something like that, okay? The sine of it was 0.8. Now when we do a diagram here, get our information on, there's my pair of information. I've got a pair and another bit of info, so I'm thinking sine rule. There it is. Notice here, sine of D is 0.8, that whole thing is replaced here. It's not the sine of 0.8. The sine of D is equal to 0.8. Now from here, some of us struggled here, should not. 8, 16. 1 and 2, 0.8 divided by 2, 0.4. Okay, we struggled on a bit of the number crunching here. We probably shouldn't have. Now it didn't ask for angle E, it asked for the sine of E. So this is our answer. This is all we need. Next one. This was a really good one, this next one. Because it was a good question because it made you think. Well, they all did really, let's be honest. It made you think. Sine of P, like above, is 0.5. Now that does tell me that P's got to be 30 degrees, remember? Exact values? Right, so didn't need that, but I kind of know it's going to be 30 degrees. But the key thing was these, when it says respectively, it's not being respectful. It's saying that that one links to that, that links to that, that links to that. The order of them is the same. So a good diagram meant you knew which order these needed to go in, okay? Because we're working out area, we want the 2 sides and the included angle. This guy, we didn't need him, we didn't want him, right? Here you go, the 12 and the 14, you see they're in there. Sine of P, numbers in. Now, we struggled calculating this, we should not. Watch this, a half of 14, 7. A half of 12, 6. 6 sevens, 42. Bingo. The number of 52s and 38s and whatever that came through, some decimals. No, look for the easy things. Units squared. Well, should have been centimetres squared, shouldn't it? Miss Warmerans, we'll let you off on that one. Calc section, here we go. Calc section. Question number 6. Great question. A few of you didn't see what was needed here, okay? And I get that. So, the sheep, they can roam anywhere this rope will let them. So they can roam out to here because stretch the rope out. They can get here. They can't get here because the wall's there. So this is the shape that we're wanting. Couple of different ways you can do it. One way you can do it is to work out the whole circle, work out this segment, take it away. That's one way. That's okay. I would probably do it a different way. I would probably work out the angle in here. We always need the angle, but work out the angle in here. Show you that in a minute. And then I would work out this sector, the major sector, this major piece of pie here, plus the triangles. I'd probably do that. So I'd probably do the sector, the major sector, and then the triangles, add them together. But you could do the whole circle minus this part here. So you can do either. That's okay. Miss Warman's workings there, I won't go through that because you can see that. I'll just scroll up a little so you can see what's going on there. Either way, doesn't matter how you do it. 298 was our answer. It did ask to the nearest square metre, so you see we've rounded it. Big issue here. Remember I said that we need to carry all the numbers through. Carry all of this, right? Carry all of this. Carry it all the way through. Round here. No earlier. Don't round any earlier. Okay? Alright, moving on. Towns. Here we go. Right, I used to live in Geraldton. Went up to Calbarry. Didn't really go out to Mount Magnet. I don't think I ever went there. Doesn't matter. What do we got to do? We've got to find GKM. We've got to find this angle here. Well, we know all three sides. Cosine rule. Got to be cosine, doesn't it? Right? So, there we go. There's the cosine rule. Doesn't matter in radians or degrees. Whatever your calculator was set in, absolutely fine. Didn't ask for any particular one. Now remember, 0.45 radians. Now remember, 1 radian, about 57 degrees. So we're looking 30 odd degrees, something like that. Okay? So that's what we're looking at. These have got to go in the right order. Alright? The angle we want, the opposite side is the one that goes here. The other two sides, here and here. Alright, we've got to get them around the right way. If we don't get them around the right way, we're working out a different angle. We switch them around, we're either working out this one or this one. Alright, next question. It looks a little bit different here. No, not this one. Next one looks a little bit different on yours. That's okay. The dog's lost. We're not going to find him. He'll find his way. Area of a triangle. Pretty easy really, isn't it? Couple of numbers in. Remember, two sides and the included angle. The included angle. Okay. Now that is the answer from up here. Alright. Units squared. So we're good there. If you got this answer wrong here, we marked it based upon your answer above. So your answer might be wrong, but you might have got this mark here anyway. We're in the calc section now, so you just throw the numbers in and you get yourself sorted pretty quick. So there we go, there's that one. Remember, use the whole number, otherwise you're a little bit out here. We're not going to find the dog in 14,000 square metres. Right. Oh, actually, you know what? Miss Warmaran's units. What are we doing there? We're in kilometres here. That's okay. Let's keep going. Okay, this will look a little bit different on yours because you've got part 1 and part 2, a little bit different setup. We switched it around. It was a bit messy here, so we switched it around. So we've got this idea here. The mechanic is going from Geraldton, found a road going directly to, well, it just means he didn't stop anywhere or go anywhere different, directly to 250 k's, and he ran into that Mount Magnet Calbarry Road. Now when he gets here, he's got to decide whether he needs to go left or right to find you. You broke down halfway along here. Does he go left or right? Well, this is just a smaller triangle, same angle, same side. We've got a new side, we just need to know this one. And that's what we get out here. Same sort of idea, cosine rule, we get that out. So where he runs into that road is going to be at 368 kilometres long. Now you broke down at 200, oh sorry, halfway I think it was. Yeah, you broke down halfway. Now this was 450, so you broke down at 225. Well, he hit at 368, so therefore he's got to turn left 100 and something kilometres along and he'll find you. Hopefully he fixes it, you're on your way. Next one, the ladder question. The ladder. So, look at this. This comes from a past exam. So this is a great exam question here. Now, what are we doing? We're laying our ladder up against the wall over here. It's 3.6 metres long. Okay? And we're some distance away. We then swing the ladder over. The base stays there. We swing the ladder over to this side. And because this distance here is different, the ladder's going to fall at a different height up the wall, isn't it? So that's the idea here. That's what we're doing. We've got a ladder that we're swinging between two walls. Find the angle which ladder is rotated through. Well, if I can find this angle in here, then can't I do 180 minus the 2 to get that? And that's the angle through which it falls. And I can do that because this is 2.6. The ladder doesn't change length, does it? Same ladder. So this is 3.6. That's how I got that. 180 minus these, 63, 64 degrees is what I'm moving through. There we go. You can see the marking scheme there. What's the next one? The distance of AB. AB is along the bottom here. Well, I've got this now, and I've got that. Can't I just use the 3.6 or the 2.6? Bit of Pythagoras, trick, right angle triangles. I can go here, I can say cos of 70 equals EB over 3.6, solve. I can say cos of this angle that I worked out here, 46. Cos of 46, no, let me do sine of 46. No, cos of 46 is adjacent over hypotenuse, 3.6. Add those two together and we'll get 3.72. 3.72, there we go. There it is. What's the next one? The distance DC. What's DC looking like? DC is here. We're there already. 3.6. 3.6. We know that. We worked that out. 63.8 degrees. Isn't this now just a cosine question? Because draw the triangle. We've got two sides in the included angle. I can work out the other one. So wouldn't I just do that DC squared equals DE squared plus CE squared minus 2 lots of DE times CE times the cos of that angle, which was my 46, sorry, not my 46, my 63.8 in there. Easy, let's have a look at the answer. There we go. Bit of cosine rule. And we find it's 3.8 metres there. Alrighty, let's go on to the next one. Next question, question number 9. Again, have a look at this. These ones are from an exam. We've stolen these from an exam, past exam. And now what are we doing? Determine the exact area of a sector enclosed by an arc length. Well, that's very similar to part A. We can use these two to find the angle in the middle, can't we? We can do length divided by radius and we get the angle in radians. Here we go. And we want to know the area, so let's use our area formula for a sector in radians. This is the one right here. We've been on the formula sheet. Numbers in, 252. Easy one. We're late in the test now, so many people are missing the chance to really see these questions. Now the last one, the diagram fell off, but you remember it. It's got a triangle here and then a semicircle, doesn't it? Triangle and a semicircle, and we want this shaded region in here. Okay, so here's the working for it. It's a bit complicated, but really we're going to work out 2 or 3 different parts and then just add and subtract the right bits that we need. Okay, this is the whole triangle, that's the whole thing. Then we subtracted away bits, but we didn't want the whole bit subtracted away because this 12, that's the little section up the top there that we kind of didn't want. And isn't that really just a segment? That's really just a segment. Alright? So you've got the diagram, I don't here. You'll see and follow this through, you'll see what's going on there. Last question. Last question. Many people didn't get to this question because time. Actually, it was quite an easy question in a way. The key thing here, equilateral triangle. That means all my sides are the same. So I don't need A, B and C or anything like that. Just call them all X. Equilateral triangle here and an area. So doesn't that mean the area is going to be half AB times the sine of C? And because I know it's equilateral, the C, the angle C, is going to be 60 degrees. So this is the half here. This is the AB, but they're the same because it's equilateral. This is the sine of C. And that's got to equal 330. And we solved that. Now you could actually do this non-calc, maybe not quite to this level, but this is going to be square root of 3 over 2. You kind of could do a little bit of it yourself. But being in the calc section, in the calculator, solve, brackets, comma, X, away you come, out you come, units on the end, and we're done. That's a quick run through of the test. Hopefully you've got all that. Please in this class, look through your test, find all the little bits. If you've got an issue with the marking, please give it to Mr. Wainwright, who you'll have, and he will collect them back and give them to you. Otherwise, take them home with you. I'm going to give you another copy of the test so that you can work it through again at home. Thanks very much, everyone. See you later.
Don't do methods.